Okay, so just having a look now at 2010 question 9. So you're given a reaction scheme similar to this, okay? And then we're asked 9 part A, name the molecule that contains no tetrahedral carbons. So these all contain double bonds. Best thing to do here is probably just to draw them out. So we have CH5OH, we have CH5Cl, and then we have C2H6. So the only one here, A, is C2H4. If I draw that out, that is what I look at. So C2H4. Part B, then you're asked to identify an addition, and then you're asked to identify a substitution. So always my addition reactions are going to be basically double bonds going to single bonded molecules. So if I look here, if I look at my ethene, okay, so my only two options are Y and V, and both of those are addition reactions, okay, so that would be an addition of HCl, that's an addition of H2, so either one of those will get you your marks, Y or V, okay. Substitution then, you're starting off with basically a singly bonded atom, and the biggest example there is our substitution of my chloroalkanes. After that, then you're asked to describe the mechanism of Y. So mechanism of Y, that is addition, okay. We've done this already, so that's your addition mechanism. If there's any trouble, there is a slide up there already for Sharon that you can have a look at that goes through that. Then you're asked to state the reagents and conditions to bring about conversion V and conversion Z. So we know that conversion V is addition, okay, and when it goes from conversion V, it's going to C2H4 to C2H6, okay. So firstly you're asked for the reagent. The reagent here is H2, okay, and please make sure you write it in the correct order, okay, because you may not get your marks. Always that's done in the presence of a nickel catalyst, okay. Next here then, we're going from C2H4 to C2H5Cl. So your reagent there is Cl2, and always the condition is UV light. So that's your reagent and conditions. Draw a label diagram to show how conversion X could be brought about in a laboratory. So we've done this as well already. Sorry, now I'll have to that's my test tube. Okay, this is my ethanol, and it's soaked in cotton wool. Okay, then I have my aluminium oxide. Okay, Bunsen burner, always underneath it, labeled of course. And then again, test tube here, beehive shelf, and then ethene collected over water. Okay, so that's what my diagram looks like. And finally then, conversion W involves a 3-step synthesis. So we're asked to draw the two organic intermediates. Okay, so if I look, conversion W is C2H4 to PVC. Okay, and if I look at my ethene is C2H4, and I have an intermediate, I have a second intermediate, and finally then I end up with polyvinyl chloride, and you need to know your repeating unit for polyvinyl chloride is that. Remember, always a plastic or a polymer is made from an alkene, okay, and ethene here is my basic alkene used for polythene, but chloroethene is what's used for PVC, and again that's something you need to know. So that's going to be the one that's going to lead onto my PVC here, okay. And in order to get there, okay, I need to add chlorine, okay. So when I add chlorine, my intermediate compound is going to be Cl. So I add in my chlorine. I then have to make my chloroethene, and that makes my PVC. So my two intermediate compounds, first one is 1,2-dichloroethane, and then my second one is chloroethene, and that's it.